Hi friends, a warm welcome to my numerical methods video lecture series. In this video, we will discuss the concept of interpolation. Here, we are going to discuss the basics of interpolation and what are the basic concepts are there and what are the application behind on that. If you talk about interpolation, if you want to say why we have to study this particular topic. For example, I will explain with a simple example. Suppose we know very well in our country, each and every 10 years only, they will take a census in our. So, suppose in case in 1985, 1995, 2005, 2015, 2025, 2035, 2045. For example, I have given here. So these are the values of X years and the population size in crore, 2 crore, 5 crore, 8 crore, 9 crore, 14 crore. So if you know the population size and each and every years, because we can't be able to take a census for every month or a quarter or 6 months once. So it will be very difficult to do that. We have because we have to spend more money for that. That's why if you know the population size in each and every 10 years, we can find the population size for each and every 3 months or 6 months. Or for example, we know the population size in 1985 and 1995. Suppose if I want to find in the middle, if you want to find in the middle, 1986 or 1990, or here if you want to talk about here, 2016 or 2017, whatever it may be, easily we can find with the help of the concept of interpolation. So that's why there is a need to study the particular topic. Before to go to this topic, you should know or you should learn the basics of differences. Finite differences, it will be n number of different they'll talk about n number of differences. So major two topics are there: forward differences and backward differences. So forward difference operator we are going to use, backward difference operator use, some other operators also there, center difference operator, but these are all the two major topics. Okay, now come to this video. So what is interpolation? If you want to talk about interpolation, finding the values between, these are the values of X and Y. Within the given data, if you want to find the value, it will be the concept of interpolation. Then extrapolation also there. So what is extrapolation? To find the values outside the given data, outside the given table. Simply if you want to say, suppose I want to find here X value at 80, what is the value of Y? At X value 80, what is the value of Y? That also. In that way, if you want to find, it is extrapolation. Right. For that, we are going there is need in the study the concept of finite differences. So finite differences, it is the easiest concept. I will explain with the help of this example, this table itself. So I am having the values of X as well as values of Y, X0, X1, X2, etc. So n, Y0, Y1, Y2, etc. Yn. So each and every value of X, we can get the value of Y. So this is the given data. Here, X values are going to call arguments. X values are going to call arguments, and the values of Y are going to call entries. So within the given range, if you want to find, that is interpolation. Outside the given range, if you want to find, that will be the concept of extrapolation. So now using this table, I'm going to explain how to find or how to do the forward difference as well as backward difference. Forward difference operator, we are going to use delta. This delta. How to define it? I have to find, I'm having data X, Y, X0, X1, X2, etc., Xn, xn minus 1, xn minus 1 and the xn. Xn minus 1 and xn. Similarly, the corresponding values are y0, y1, y2, etc., yn minus 1, yn. So I have to find the first difference. First difference for y0, because the forward difference will take the first value. For backward difference, we have to consider the last value. I will explain that later. Delta y0, I'm going to define, which is equivalent to y1 minus y0. Next value minus that particular value, y1 minus y0. Next, I have to define delta y1. How to define? Yeah, exactly. It is y2 minus y1, guys. That's it. Similarly, we can define for up to delta yn only we can find, because next value is yn, previous value is yn minus 1. That part. Up to yn, oh yeah, delta yn minus 1, yn minus yn minus 1, because we can't able to find the forward difference for yn because we don't know the next values. That's it. These are all the concept involved in first difference. Look at that, delta y0, y1 minus y0, delta y1. Similarly, delta y2, delta yn minus 1. That's it. Then second difference, how to find the higher order difference? Suppose I have to find del square of y0. Then how can I do that? It will be delta of delta y0. So simple. So it will be delta of y0 is delta y0 is you know very well, y1 minus y0. Good. Then apply delta for this. It will be delta y1 minus delta y0. Now apply the concept. Delta y1 will be next value minus that value. Am I right? Forward difference. y2 minus y1 minus of delta y0 is next value minus that value, y1 minus y0 is equivalent to y2, there will be minus 2y1. If you multiply by minus, it will be y0. That's it. This is the way to find the second difference. In the same way, we can proceed for the higher differences. This is only for if you are a student, only for MCQ purpose, you can go through the topic. They won't ask the derivation that and all here, right? So look at that, del square y0. As I told you already, this is the way to find this value only we have found already. Similarly, del square y1 I can find, del square 1 n minus 1 I can find easily. And third differences, del cube y0. It will be del square y1 minus del square y0 and del cube y1. And that way we can go for higher differences. Now I am going to define the concept for function. It is so previously for it is argument. Now I am going to define for function. How to define for a function? Y of delta y of x or a delta f of x, whatever maybe you can write that. Delta y of x is equivalent to, what is the next value? It should be x plus h. So it will be y of x plus h minus that value, y of x. That's it. If it is a function, this will be the concept. It will be take place for MCQs. Right. Then how to find del square? Del square f of x, delta of f of x. Then the similar way we can proceed here. In the place of y, we are having f of x. That's it. There is nothing apart from that. So delta of f of x plus h minus delta of f of x. Delta f of x plus h, next value minus that value, f of x plus h. And then for del f of x, delta f of x, it will be next value is f of x plus h. That value is f of x. That's it. This is the way to define the forward difference. Similarly, we are going to see how to define the backward difference operator. Backward difference operator we are going to use, there is this del, that one we will call it as delta. Backward difference operator is going to call as a del. Then how can I find the values for given arguments and entries? I have to find del y. So here we have to, this is backward operator. So del yn, etc. del y2, here del y1. Del y0 we can't able to find because the previous value won't be there. So if you want to find the value for del of, I mean difference, first difference for del y1, it will be that value minus the previous value, y1 minus y0. So it is the same as for delta y0. Do not confuse both. This is delta y0, previous and for forward operator. That is y1 next value minus that value. Here, if you want to talk about, so for forward, simply if you want to say, I am in this position, another position, this is front, another position is it is back. So forward operator, if you want to find, so it will be next value minus this value. This is delta. Backward difference operator. How to define del? This value, that current position value minus the previous value. It is going to call del. This uh, representation will help you to understand the concept easily, I think so. Right. Now come to the point. Del y1 is y1 minus y0. Then how to define y2? Yeah, we can easily answer for that. Yes, exactly. That value minus the previous value. Then how to define del yn? That value minus the previous value. That's it. That's it, guys. This is a way to define the backward difference operator. This is first difference. Similarly, yeah, look at that. That's it. Similarly, I can define for a function. How to define for a function? I'm having del y of x. Here I have given f of x. You can take y of x. Del y of x backward. So that value y of x minus previous value it should be y of x minus h. That's it. This is a way to define if it is a function. Apply the backward operator concept if it is a function. That's it. Similarly, we can define for second difference, backward second difference. That's it. Look at that. That's it. Now, easily I can explain those things with the help of this simple example, with the help of this simple difference table. Actually, here I have given it is a forward difference table. No need to bother about that. For backward, we are not going to find a difference table, different table. For both, we can take from this table itself. So x values are arguments, y values are entries. Now I have to find del y. Yeah, tell me how to find it. You know very well. y1 minus y0. It is del y0. y2 minus y1. It is del y1, delta y1. Similarly for delta y3 minus y2, it will be delta y2. In that way, we can define everything. This is for first difference. Delta y0, delta y1, delta y2, and then delta y3. Second difference. How to do the second difference? This value minus this value. It will be delta square. Forward means y0, backward means the last value. We have to write that. That's it. That is the thing. There is nothing apart from that. Right. So this is second difference. Next, third difference. This value, next value minus that value. While we are solving the problem, I will explain the concept once again. So it is better to find the differences. If you want to find the difference table, it's better to find from the last minus previous, last minus previous. In that way, if you are coming, you won't commit any mistakes. Right. That's it. This is del cube. And the fourth difference is this. That's it, guys. This is the concept we end on forward difference and backward differences. Right. Now come to the concept of interpolation. Already we discussed it in the beginning. So it is a process of finding the values within the given data, given set of tabular values. That's it. This is the way to define the concept of interpolation, finding the intermediate values, simply if you want to say. Right. This is the given data x and y. From that one, If you want to find in the middle, that is going to call interpolation. Now come to the part of extrapolation. It is finding the values outside. That is the important thing here. Finding the values outside the given data is going to call extrapolation. But for both finding the intermediate values and beyond that, if you want to find the particular value of y at a particular value of x, we can apply interpolation concept itself. That's why in this video we are going to deal the concept of interpolation and what are the formulae or what are the methods are available here, that and all we are going to discuss in the upcoming slides. Yes, as I told you already, we can apply for both finding the intermediate values and outside the values, we can apply the interpolation concept. Right. In interpolation, we are having two major concepts, guys. Interpolation can be divided into equal interval, unequal interval. So equal and unequals are nothing but x values. Look at that here. X value, if it is equally spaced, for example, it is here 10, 20, 30, 40, 50, 60, 70. Yeah, it is equally spaced. Here also 10, 20, 30, 40, 50, 60, 70. Suppose if it is unequally spaced, 10, 30, 45, 56, 60, 70, likewise. See, look at that. X values are unequally spaced. This is the concept. Two topics are here. Whether X values are equally spaced and X values are unequally spaced. What are the, if it is equally spaced, we are having three concepts, three formulae. One is Newton's forward interpolation formula. This one. Another one is Newton's backward interpolation formula and Lagrange's interpolation formula. So I have given separate video for Lagrange's interpolation formula because it is applicable for both. Look at that here. It is interpolation for unequal intervals. For unequal intervals, we have uh, divided difference formula and Lagrange's interpolation formula. You can ask the question, sir, you have given both in that place. There also Lagrange's interpolation formula, in unequal also interpolation formula. Yeah, that is the beauty of Lagrange's interpolation. It's applicable for both equal and unequal. Particularly if they specify you have to use that method, we can go through that method. If they did not specify any method, yeah, you can solve for Lagrange's also. Right. So particularly if you want to say for equal interval, we are having Newton's forward interpolation formula, Newton's backward interpolation formula, and for unequal intervals, we are having Newton divided difference formula. So as I told you already, how to identify whether it is equally spaced or unequally spaced. We have to check the values of x only here. That's it. Right. So in equal intervals, as I told you already, there are three formulae: forward interpolation formula, backward interpolation formula. Lagrange is having a different concept, so that's why I have added a separate video for this. Please go through that. Interpolation with unequal intervals. Newton's divided difference formula. Mainly, we are going to discuss with this. Right. In this video, I'm going to continue with interpolation with equal intervals. Right. So here, as I told you already, there are two formulae: Newton's forward interpolation formula and Newton's backward interpolation formula. What is the formula? Y of x is equivalent to y naught. This is the first value plus u. Here u is nothing but the difference in the x. U of u plus that x is equivalent to x naught plus u into h. This is what you. Next value, if I are giving u equal to 1, it will be h, u equal to 2, 2h, 3h, it will be like that. So y naught plus u into del y naught plus u into u minus 1 by 2 factorial del square y naught plus u into u minus 1, u minus 2, divided by 3 factorial del cube y naught plus u into u minus 1, u minus 2, u minus 3 by 4 factorial del power 4 y naught plus etc. Here, as I told you already, x equivalent to x naught plus uh. That is, if you want to find the value of u, it is nothing but x minus x naught divided by h. X minus x naught divided by h. This is the formula we are going to use. So, particularly this and this will be important one here, equation 1 and this one. This is in forward interpolation. Next, in backward interpolation. So, if you know forward difference, forward interpolation formula, it will be easy to write the backward interpolation formula. I will tell you what are the different things here. Here we are using forward. I mean, why not for forward interpolation formula? For backward, instead of y naught, I will use yn. Second thing, instead of the forward operator, I will use backward. Third one, instead of u, as some other authors they used v. Here also I have given the concept. You can use u also there. It won't be the major difference. Yeah, even in my class, I used to give like that only with one variable only. I will give you. I have given there. Right. The last one is, fourth one is, everything will be plus here. Whatever the place you are getting minus in the forward interpolation, we will get plus. So if you know the forward interpolation formula, using this clause, we can easily write backward interpolation formula. So if you are a student, I would like to give one information. Do not skip this video, because while you're solving the problem or giving the formula, I will give some important tips and tricks. If you skip it or if you forward it, you can't be able to understand the concept. Because using that tricks and the tips, you can easily solve this problem, and you can come to the conclusion whether your answer is right or wrong. That clue also I will give while you are solving the problem. Because that's why do not skip it. Okay. In the similar way, I'm giving the tips now. These are the clues, right? Using the forward interpolation formula, easily I can write backward interpolation. So simply I will change y naught by yn, and the operator forward is backward del. Here delta, that is del, and instead of u, I am going to use v, and then here u minus 1, u minus 2, everything. So minus signs are there, everything will be plus there. Now come to that point. Yeah, interpolation with the and equal intervals only we are discussing. Newton's backward interpolation formula. So what are the differences I have given? Instead of y naught, yn. Yeah, exactly. And then operator is going to change del. And instead of u, we are using v. That's it, guys. And everything is plus. You just go through the four clues. Easily you can understand the concept of backward interpolation formula. Here, how to find v, the value of v. V is nothing but here x equal to xn plus vh, v equivalent to x minus xn by h. In forward, it will be x minus x naught divided by h. Forward, everything will be first value. Backward, everything will be last value. It's a simple clue to avoid mistakes. That's it. So these are the basic in our finite differences, guys. In the upcoming video, we are going to solve some related problems, interpolation with the equal interval concepts. I think this video will help to understand the concept of finite differences and the basic concept of interpolation and the extrapolation. Okay, guys, we will join in my next video. If you like this video, subscribe it. Then only you can get the update if I am adding any videos. And don't forget to share it. Thank you. Thank you all.